Okay, we're going to take a look at, so we've been looking at base brakes, which involves brake pads, calipers, master cylinder, vacuum booster, steel brake lines, rubber brake hoses. And what they did to make the brake system better, to enhance the operation, we added something called ABS. As you can see here, ABS stands for Antilock brake system or anti-lock braking system. So it's basically an add-on system to our existing brake system. And basically it started in the 80s is when it started appearing on cars and trucks, 1980s. And then at the beginning it was more of an option. That meant that you had to buy it as an extra. Like when you bought your new car, you'd have to check off the box that says, I want ABS on my car, and it might be an extra $1,000. So if the car was $15,000 brand new back then, it would be now $16,000 because you'd add the $1,000 option. Nowadays, most cars come with it as standard equipment. So that means you don't have to check off the box when you buy a new car. It comes with it right from the factory. There are some exceptions. If you buy a pretty cheap, inexpensive car, like the introduction model, like the lowest priced model that maybe Toyota offers or Ford offers, it may be not on that vehicle. So we'll show you how you can tell if your car has ABS or not. We'll show you a couple different ways to figure that out. So I just wanted to look at these three things that are on this sheet here. This is going to be in your module. It's related to a video that you guys just watched, some of the advantages of having ABS. So there's three things here to make a safer stop with ABS systems or anti-lock brake systems. One of the things that it will do for you is it stops in a shorter distance. So if you're stopping and let's say there's some obstruction in front of you at 300 feet, maybe the ABS system will allow you to stop within 250 feet. So that would be good because you only have 300 feet before you hit that obstruction. So without ABS, it might take 350 feet to stop. Whereas when you're stopping with ABS, it'll be 250 feet, which will mean you'll stop before you hit the obstruction in the road or the wall or whatever you're running into. The other advantage, so one of the first advantages is stopping straight, or basically stopping with the shortest stopping distance. The second one is stopping straight. So that means when you're stopping on a road that's crowned, that means the road isn't completely flat. It's kind of curved where the center of the road is higher than the curbs of the road. And the reason they do that is when it rains, they want the water to drain to the sides of the road, so it kind of drains down and drains away. The problem with that with cars is if you're on any slippery surface, let's say it's icy and the car's on a crowned road, the car will tend to slide towards the side of the road, which is where cars are parked and the curb is. So with ABS, because the wheels will not lock up or stop spinning, they actually are controlled the amount of time that they stop. It's roughly 28% wheel lockup and 78% or it's basically going to allow the wheels to still rotate and stop and rotate rapidly 10 times a second. And that will allow you to be able to stop straighter as compared to just sliding. The third item here is to steer the vehicle while you're braking. So the only way you can steer a vehicle while you're braking on a slippery surface is the front wheels have to still be rotating. So if the wheels are rotating, let's say 88% of the time and braking 22% of the time during a panic stop, because the front wheels are still rotating, you can still steer the car. So if you're heading towards a tree or a telephone pole or something in the road that you want to avoid, you'll be able to still steer the car while you're stepping on the brake pedal with full force And that's because the front wheels are still rotating 88% of the time and braking, let's say, 22% of the time. Well, basically, we're using the rotating wheel to be able to allow you to still steer the car. Now, before we had ABS, they used to tell us to pump the brake pedal. So like when you were stopping a car and you were on a slippery surface, they told you to pump the brake pedal so you'd be able to steer the vehicle as you're braking. Nowadays with ABS, you're only supposed to hold your foot solid on the brake pedal. You should never pump the brake pedal, because when you pump the brake pedal, you disable the ABS system. So you're kind of defeating the purpose. So the way you brake a newer car with ABS is you hold steady pressure on the brake pedal, you don't pump the brake pedal, and then you can stop shorter stopping distance, because the computer will activate the system to allow you to get the shortest stopping distance, and it'll also allow you to steer the vehicle, and it'll also cause the vehicle to stop straight. So those are some of the advantages of having ABS. Again, we're locking the wheel up for roughly 88%, actually allowing the wheel to still spin for a period of time so we can still steer the car. Now what I did was, we're going to look at all the different components that make up the ABS system. So I have another handout that I'm going to put in your module, and that's related to all these different components. So this is what this module handout looks like. We're going to go through these different things. I have a lot of them on the table here that we're going to take a look at. So I want to start up in the top left-hand corner. You'll see there's a brake pedal, and the brake pedal is exactly the same as the older cars. There's no difference there. Most cars have power brakes, so we still use what we call a vacuum brake booster, which again is there to assist when you're driving the vehicle to make it easier for you to apply the brakes. We still need a standard master cylinder, and again, that's the storage for the brake fluid, and it also stores and allows pressure to build up when you step on the brake pedal inside the master cylinder to be sent down the tube, which is a steel tubing, which allows pressure to be built up into the system. So these three components, the brake pedal, the vacuum booster, and the master cylinder, are identical to the non-ABS equipped vehicle. All right, so the first thing we run into from the line that comes down, we go into this new component right in the center of the page. This is called the hydraulic modulator. As you can see here, it says hydraulic modulator. Here's what a hydraulic modulator looks like. We're going to show you where it is on the car or the truck. There are different locations. A lot of times they're under the hood, and these fittings that you see, these holes where the pipes would go in, there's 4 of them here. And then if you look at the front, these two that I'm touching right now are the inlets from the master cylinder, and these 4 go to each of the 4 wheels. So there's going to be tubes like you see in the picture here coming out of the top of the hydraulic modulator that goes back to each of the 4 wheels. So this is basically the component in the ABS system that pressurizes and depressurizes the brake fluid rapidly, 10 times a second, to keep the wheels from locking up, and also give you the steering ability and the straight stopping ability. So again, this is the hydraulic modulator. Also, by far the most expensive part of the ABS system. These can cost up to $1,000 for this piece when they're brand new. Sometimes you can get them cheaper now. If you get a used one, you can actually find them at a salvage yard for a couple $100. Or you can buy a rebuilt one for half the price of a new one. So they are fairly expensive, but they're very important. When they fail, your ABS doesn't work anymore, you'll have regular brakes. So you never are without brakes. You're basically going to be out without the ABS function. Okay, so again, hydraulic modulator. It's an electrical device. Has lots of wires going to it. This particular module has a computer mounted onto it. This is actually the computer part of the system. So we'll show you a couple different computers. It also has a motor on it, an electric motor for pressurizing, depressurizing. It actually goes through 3 stages, which we'll talk about in more detail. So we have pressure increase, we have pressure decrease, and we have pressure hold. So it can rapidly go through those 3 cycles. Again, increase, pressure hold, and pressure decrease 10 times a second on one wheel that might be locking up. All right, next component that we have in our picture, if you look down in the bottom right-hand corner, here's our electronic control unit, ECU, they abbreviate that. That's the computer. So on some vehicles, the computer's mounted right on the unit like this one is. On some systems, it's a separate box. So this is actually what the computer looks like for the Antilock brake system. You can see there's lots of terminals. So when you plug the connector in, you got lots of wires leaving and coming into this. On this particular vehicle, this was located under the passenger seat, under the carpet. So you actually had to find this. If you had to get to it, it was under the passenger seat on this car. This can be located under the hood. It can be under the car somewhere. Sometimes you have to look around and find it. So again, this is the computer that stores trouble codes. We'll get into what codes are. So if there's a malfunction in the system, this will actually store the malfunction. And then if you use the right tool called a scanner, you can actually communicate with this computer and it will tell you why, what was wrong with the system to help diagnose it. It can also turn on the anti-lock brake light. So when it sees a problem with one of these components, it will turn the anti-lock brake light on, indicating to you that it's not working. That actually means that there's a trouble code stored in the computer, and it also means the system is shut off. So whenever the light is on, if you're driving a car with the ABS light on, you do not have ABS. That means those features, shorter stopping distance, stop straight, and steering control, that all goes away. All right, also on the dashboard, we're gonna have some kind of warning light. Now, so in this case, it's called the anti-lock brake light. Sometimes they abbreviate it ABS. I don't know if you can see that in here, but we're gonna look at it on the vehicle. So when you turn the key on, all the lights on your dashboard should light up as a bulb check. And when there isn't a problem, when you start your car up, that light should go off within a couple seconds. So when you just turn the key on without starting the engine, the light will come on just to make sure you know the light works. But if there is no problem in the system, the light will go off, which means that the system's active and it's okay. If the light remains on after you start it up, that means there's a trouble code stored in the computer and the system is deactivated. So now you're gonna have to try to figure out why. This light here is an amber color. It's like a yellow-orange color. And what yellow-orange means on a car or vehicle, that means that you have to drive with caution. So that means you can still drive the vehicle, but that means you have to be very cautious when you're driving. If it's a red light, one of these other lights might be red. That means you should get it fixed immediately. That's a danger light. So a light that says brake, that would say, would be a red light, that's an indication that you should discontinue driving that vehicle immediately and figure out what's wrong with it. Anti-lock brake light, being amber color, you can continue to drive until you get, at your convenience, you can get it repaired. So we'll talk more about different color lights. All right, so that's on the dashboard, right by the steering wheel. When you turn the key on, that light should come on for a bulb check and then go off if everything's okay. All right, next thing we have, the last thing we have in this picture is our wheel speed sensors. At each wheel, the computer needs to know exactly how fast each wheel is spinning. So if you have, depending on if you have a front wheel drive car or a rear wheel drive car or an all wheel drive car or a 4-wheel drive vehicle, they do it a little differently, but really there's 2 different styles. This particular one that you're seeing here, if you look closely, this is called the axle, and actually this is what an axle looks like, this piece right here. This goes into your transmission on this end, and this end is where your wheel is attached. So your wheel, think of this part here with the studs being attached to the end of this, and that would allow your wheel to get mounted. So this whole shaft here, which is called it's basically an axle shaft, half shaft, they call it, because there's two of them. There's one on one side and one on the other side. This is spinning when you're driving the car. Now, if you notice, if you look this right here on the axle, you'll see a tooth ring. You can kind of see it here. That ring is part of your anti-lock brake system. So what we do when the vehicle's driving down the road, this thing's rotating. We're going to take this piece right here. This is actually what we call a non-integral wheel speed sensor. So this is a sensor that's not built into the hub. It's a separate piece that you can replace. And this is actually mounted, if you look at the bottom, see that little metal tip there? That's a magnet. That magnet has to be very close. When we mount this onto the car, we're gonna have this almost touching this ring, but not touching it. It's mounted in a position where it can sense the teeth of the ring going by the end of the magnet. And that's actually gonna generate a signal that will tell the computer through two wires that you see inside here. There's two terminals in there. It's gonna send a signal out, which is an AC sine wave, and we'll talk more about that, back to the computer to tell the computer exactly how fast that wheel's spinning. So we're gonna have 4 of these, one at each wheel, that is wired back to the computer, and it actually tells the computer how fast is the left front wheel going, how fast is the right front wheel going, the left rear and the right rear. And basically what it's gonna tell the computer, if one of the wheels is slowing down too fast, it will tell the ABS computer to pulsate the pressure with the hydraulic modulator to the wheel that's gonna lock up to hold the pressure, relieve the pressure, build up the pressure rapidly, and it's gonna try to keep the wheel from locking up. So basically it's constantly monitoring all 4 of these wheel speed sensors to see if one of the wheels is slowing down too fast. If it is, the computer kicks in, tells the hydraulic modulator, pulsate the wheel pressure to keep it from locking up, and it's gonna monitor it, watching the wheel speed sensor. Once it sees everything stabilized, because all the wheels are rotating at the same speed, the computer will tell the hydraulic modulator to stop pulsing the pressure at that wheel. So that's kind of how the ABS system monitors each wheel. So this is again called a non-integral wheel speed sensor, which means it's a separate independent sensor that can be replaced. They're about $30 to $60 if you have to buy one of these. Let's look at what an integral wheel speed sensor. If you look at this one here, this is actually a hub. You can see this is where you bolt your wheel on. There's your studs sticking out where the lug nuts go on. This wheel speed sensor is actually built into the hub. So when you have to purchase this particular wheel speed sensor, you have to buy this whole thing here. It doesn't come off. It's not an independent, non-integral wheel speed sensor. So an integral wheel speed sensor is all one piece. Problem is the money goes up. So we said this one here is about maybe $30 to $60. This is anywhere from like $50 to about $350 depending on the car. So this can get pretty expensive because you have to buy not only the sensor but the whole hub. So this works the same way. You got 2 wires coming out, and these 2 wires send a signal back to the computer, and it monitors the speed compared to all the other wheels. And if it sees that wheel slowing down too fast, it will pulse the pressure at the hydraulic modulator and keep this wheel that was going to lock up from locking up. So that's basically how that works. Here's another example of a wheel speed sensor. You can see it's part of the hub, so this is an integral one. Here's a hub without a wheel speed sensor. You can see there's just a cap on the end. So on some cars that don't have ABS, this is what the hub looks like. When you replace it, you have to take these 4 bolts out, and you can replace this whole piece right here if you need to. There's a bearing inside here, and it goes bad sometimes. And if you're driving a car that has a humming sound coming from a wheel, it's like a constant hum. That's because the bearing inside this hub is going bad. You got to replace this whole piece. A little less money because it doesn't have the wheel speed sensor as part of it. So you're looking at maybe $100 here compared to 100 plus, whatever that's going to cost. Here's a couple other wheel speed sensors so you can just see what they look like. This is one that has a wire. We call it a pigtail coming out. So if you have a sensor that has its own wiring when you buy it, that's also still a non-integral, because you can buy just the sensor. That's what that looks like. Here's another wheel speed sensor. These are all old parts that I've saved. These are bad parts, but same basically design. It has a magnet inside, a coil of copper wire, and we're gonna learn how that works. This will actually generate an AC voltage when the wheel's spinning. Tell the computer that there's a problem. This one's a little different too. That's also a wheel speed sensor. I cut one open once to see what was inside it, a wheel speed sensor. All this really fine copper wire came out of one wheel speed sensor. And this is all one piece that's kind of tangled up, but this would probably stretch across a football field. That's how long this piece of wire is. It's like the thickness of your hair. Very, very thin wire. And they have it wrapped inside. If you cut this open, it's actually inside this part right here. I had to take one apart to get it out of the mounting, and all this started coming out of it, so I saved that. All right, we're gonna come over to the vehicle for a minute and just look at where some of these components are located. This is one of the cars that were donated, a Saturn. And you can see, if you look back here, you can see the master cylinder cap. You can see the the vacuum booster back here behind the master cylinder. So that's pretty much the same. If you look down under here though, you'll see, oh, that looks familiar. That's your hydraulic modulator on this car. So you can see there's two lines going in down here, these two lines. So this is actually coming from the master cylinder over here. There's pipes that run around and make it over to here. So these are the inlets. There's two pipes coming in. And then these four coming out on the top are going to each of the four wheels. So they split. One goes to the left front wheel, right front wheel. And actually can even see it. They have it printed on here. If you look closely, it says LR. That's the left rear. Over here, I don't know if you could see it. RR is right rear. So they actually tell you which line goes to which wheel. On my truck here, I have it up in the air because I wanted to show you where my hydraulic modulator is. They kind of hid it. And it's not in the best place, but it's actually under the vehicle. And if you look right here, that's where my hydraulic modulator lives. It's underneath here. You can see some rust because this came from the Northeast and we get a lot of snow there. And they actually have the computer under here too, so that's not so good. But that's where they mounted it. Seems to be okay. At each wheel, can't really see it in here too good, but here's your axle that I was talking about. You can see how the axle comes across, goes inside the wheel in the back here. And this has an integral wheel speed sensor, so it's built into the hub. I know it because I had to replace it. I wanted to lower the vehicle down so you can look inside the vehicle. So let me lower the lift down for a minute. And I want to show you the lights on the inside. Then we're going to take a quick look at the scan tool, because you're going to be using that to do some diagnosis in the future. All right, so I'm lowering the vehicle down to the point where I can get in. All right, so we're going to come over and just look at the dashboard. When I turn the key on, I want to see kind of how it responds to that. Okay, so let's take a look. All right, so I'm gonna get in the vehicle. So if you're gonna buy a car and you wanna know if your car has ABS or not, when I'm putting the key in the ignition, just turning the key on, you can see over here, a whole bunch of lights lit up. Okay, let me shut the key off. So it's gonna do a bulb check. So you have to kind of watch, see the one light that says ABS there? Okay, so that means the system at least checked the bulb. Check engine light is still on. That little engine symbol, that's also an amber color. There's the seatbelt warning, which is red because that's danger if you don't have your seatbelt on. This light over here that's blinking is the low air pressure light, which when it's blinking, that means one of the sensor's battery is probably dead. So I have to replace that. But let me show you, if I start up the engine, right now, well, see the brake light is on, the red brake, and now it's off. Let me start it up. Okay, all the lights should go off once it starts up. Okay, you can see, well, except for the seatbelt, unless if I put my seatbelt on. So I'm gonna close the door. If I put the seatbelt on right now, you can see everything went off now. That's good. Hood's open. If I unhook my seatbelt, you can see that light comes back on. Plug it back in. All right, so that's a good sign. The only light that's still blinking is my low air pressure light, which means one of my sensors needs to be replaced. Also have that green thing is my headlights. So right now, because I'm inside the shop, it thinks it's kind of dark. It automatically turns the headlights on. All right, so I just wanted to show you that. We'll shut the engine off again. If you turn the key on, it should do a bulb test. Let's just identify some of these other lights. So we have oil pressure, which is this, what looks like an oil can up there. It's red. We also have a battery symbol with a plus and a minus on it. It's also red. So this is low oil pressure if your oil light is on. Your battery light is if your charging system's not working properly. If you have this one in the center on while you're driving, that means your airbag or your supplemental inflatable restraint system's not working properly. And there's also a theft deterrent, which is this thing with the lock. That indicates that your system's alarm is on. So if somebody tries to get into your car with that activated, it'll start honking your horn. All right, so these are some of the lights that you might see when you turn the key on. I wanted to show you underneath the dashboard, under the steering column, there's going to be a connector. And this is where we're going to be plugging our scan tool in. I don't know if you can see it real good, but let's take a look. All right, so I'm going to point to it. This is it right here. It's like right underneath the instrument panel. It's a 16-pin terminal. Okay, there's only maybe 6 wires in there. And on our scan tool that we're going to be using, this is the scan tool that we're going to be looking at. There's a Bluetooth adapter, this piece right here, that's going to plug into that connector. So if we take this and plug that in, now this is a 16-pin connector. All cars built after 1996 use the 16-pin OBD2 connector. That's onboard diagnostics generation 2 connector. Anything after 96 sold in the United States has to have this style connector that you can plug this tool into. This is mainly for the inspection stations, but you can also use this for the scan tool that we're going to show you. Okay, so I'm going to turn the key on and just show you the scan tool. Now, I don't have to sit in the vehicle because this is basically wireless. So if I come out here and I power this tool up, let me just, up here is a red button. That powers the tool up. We'll give it a second to come up on the screen. Trying to find a spot where it's kind of dark. Okay, so we'll give it a second. Okay, it's a Matco tool. Snap-on makes tools, Matco makes tools. Craftsman, you probably heard of that. These are different tool manufacturers. Once the scanner boots up, it's really a computer. It has Windows on it and everything. How much is it? Like $1,800 for this tool. One thing interesting is it pretty much does every type of vehicle. You'll see it in a second as soon as we power up. Okay. All right, so here you have like all these different vehicles you can pick from. So as you can see, as we scroll down, you have all these different types of vehicles, just about anything you could possibly think of. Even has Lamborghini, wow. Maserati, Rolls-Royce. So if we go down to Cadillac, which is what we're looking at, so you just click on Cadillac. Okay, it wants to know if you have more than one V version, you're gonna pick the latest number. So this only has one choice. If I had more than one choice, I'd wanna pick the latest version. Down here it says confirm. So it says I wanna pick that one, just hit confirm. Connecting Bluetooth, loading. Okay, I'll give it a second. So we're going to get into more using this tool. I'm just trying to show you a quick introduction to it. All right, here you have to tell it what the VIN number is. That's the vehicle identification number. It can do an automatic search. If I hit automatic search, automatically search, it already found what the VIN number is. It's a 17-digit number that you can see there. And I know that's my number there, so I'm going to just say yes to that. Okay, this is identifying what type of vehicle it is from the VIN number. It's a 2007 Cadillac Escalade with all-wheel drive. AWD is all-wheel drive. We'll say yes to that. Okay, at this point, I want to select system selection because I want to pick the ABS computer. This is going to find all the computers on the car, which there's probably at least 20 computers on this car. One of them is the Antilock brake computer. And we're just going to take a quick look and see what that is. Okay, so you see here we have the ECM, which is the engine control module. That's the engine computer. You got the transmission control module, which is for the transmission. There's a computer for the radio, assist step controller, body computer, an auxiliary body computer, digital radio receiver, driver's door switch is a computer, air conditioning, HVAC is heating and ventilation and air conditioning. Even the mirror has a computer for the mirror, rear mirror. Instrument cluster, the lift gate has a computer, the memory seat has a computer, the park assist has a computer, passenger door has a computer, personal audio link module. You have a radio, rear heated seat module, rear air conditioned seat module. You have a remote control, you got a rollover sensor, you got a supplemental inflatable restraint computer for your airbag, you have a theft deterrent module. Here's your vehicle communication interface module. Here's the EBCM, which is electronic brake control module. That's your Antilock brake computer. All right, so I'm gonna click on the EBCM, which is the Antilock brake computer. All right, I can read information here. So I have, either I can read trouble faults, or they call them fault codes. We'll look into doing that. But if I had a light on and I wanted to know what was causing the light to come on, I could click on that. I don't think I have any faults right now, but I'll just check. DTC display. Okay, it's looking for any faults. Right now it says no trouble code, system normal, which is what I was expecting because I don't have a problem in there right now. I'm backing up. There's actually a little backups arrow here. That's the backup. Every time I hit that, I go back one step. If I want to read data stream. Computer's going to communicate with the scan tool. I have to pick what I want to look at. Let's say I want to look at the wheel speed sensors. Here's the left front wheel speed sensor. If I click on that, it puts a little check mark in there. I want to look at the right front wheels. Here's the left rear. That's the left front. I'm looking for the right rear wheel speed sensor. Here's the right front. Again, if I put a check there, that means it's gonna pick it up. And then this one's the right rear. And if I hit confirm now, okay, it's gonna bring up those 4 wheel speed sensors. Okay, so look at that. So you have the left front wheel, the right front wheel, left rear, and right rear. And right now the value on each of those is 0. and the unit is mile per hour. So if you were driving the vehicle right now, you'd actually see like 5, 10, 15, 20 as you were driving. You could actually monitor the wheel speed sensors as you're driving. So we're gonna check those out when we look into how to test wheel speed sensors. Okay, so that's basically our quick introduction right there. Again, I just wanted to show you a couple things that we're gonna be doing. Scan tool is a big part of it because that's gonna tell us a lot of information about our system to see if things are not working properly. Okay, it's saying, okay, just wanted to warn me. Okay.